The National Metrology Institute of South Africa, NMISA, is a Category 3A state-owned enterprise established through an Act of Parliament, Measurement Units and Measurement Standards Act No. 19 of 2006, to be the custodian of national measurement standards and units through consistent and appropriate application of relevant measurement units and the International System of Units, SI. The National Metrology Institute of South Africa, NMISA Material Characterization Section undertakes R&D projects that focuses on producing reliable and fit-for-purpose materials measurement services to industry. This is enabled by its internationally comparable measurement expertise and investment into high-end equipment. The NMISA Materials Characterization facilities enable measurement traceability to internationally agreed-on standards. Recent examples of materials characterization services related to measurements for health includes the surface analysis of dental implants, particle size monitoring, and quantifying the amount of asbestos in dust from derelict and ownerless South African mines. X-ray Photoelectron Spectroscopy (XPS) is an advanced materials analysis technique that is used to investigate the surface chemistry of solid samples. The technique is based on measuring the energy and number of electrons emitted from the material's surface when irradiated with an X-ray beam in a high vacuum, which in turn allows for the quantification of elements present in the sample surface. The surface composition of dental implants is a crucial factor in determining their suitability to be successfully integrated into bones. As a result, accurate and reliable surface characterization is vital in understanding the surface properties of implants and the effect of surface treatments on the biocompatibility of dental implants. XPS is the most dependable surface analysis technique that quantifies the surface chemistry of dental implants and therefore provides valuable insights for manufacturers into commercially available implants. Particle size distribution (PSD) is an established materials characterization analysis technique that focuses on determining the size and shape distributions of particulate matter. PSD is typically measured using microscopic imaging by light or laser scattering or diffraction of dispersed particles. The measured imaging and light diffraction data are analyzed against advanced software modules designed for analyzing a high number of particles. The particle size and shape can have lasting negative impacts on the health of individuals and the environment. Prolonged exposure to silica particles can lead to silicosis, and the continuous emission of particles into the environment can induce acidification of water sources, which in turn have devastating impacts on wildlife and plants. Particle size analysis is highly regulated in South Africa, and NMISA plays a central role in supplying particle sizing services that covers different size ranges from 150 nanometers up to 3 millimeters for samples with a low and high number of captured particles. Scanning Electron Microscopy (SEM), equipped with Energy Dispersive X-ray Spectroscopy (EDS), is a powerful modern-day materials characterization technique that provides morphological and elemental analysis at high resolution. The technique benefits from the small wavelength of a high-energy electron beam that surpasses the resolution of normal light microscopy and that also induces the emission of characteristic X-rays with energies unique to the elements present in the material under investigation. This enables SEM-EDS to view the size and shape of particles as well as determine their elemental distribution. The emission of dust from derelict and ownerless mines in South Africa is a major concern, as the sizes and shapes of hazardous materials such as asbestos can have devastating effects on the surrounding environment and the health of communities that live around these mines. The NMISA Materials Characterization Laboratories collaborated with the Council for Geosciences (CGS) to develop reliable and fit-for-purpose SEM-EDS measurement protocols to quantify the size and shape distribution of particles originating from the abandoned mines. X-ray diffraction (Xrd) is a technique that is used to determine the crystallographic structure of materials. Xrd is based on the constructive interference of incident X-rays at specific angles with the crystallographic plans within the crystals composing the sample. The advent of super-fast X-ray detectors and ability to analyze large numbers of samples enables Xrd to be a bulk analysis technique with a quick turnaround time. NMISA provides XRD services that are traceable to the International Center for Diffraction Database, ICDD, in the case of analyzing minerals from derelict and ownerless mines. XRD is indispensable in identifying and distinguishing between the different types of minerals, especially asbestos, and determining their relative amounts. NMISA is part of the Department of Trade, Industry and Competition's, the DTIC, family of technical infrastructure TI institutes, which also include the South African Bureau of Standards SABS, National Regulator for Compulsory Specification NRCS, and the South African National Accreditation System SANUS, that together provides for confidence in local goods and products and allows for successful prosecution in cases of non-compliance. The accuracy of measurement results can be demonstrated by ensuring that these are traceable to the National Measurement Standards, Government Gazette No. 1131, 19 October 2018, realized and maintained by NMISA. For more information and queries, visit our website www.nmisa.org or contact us on info@nmisa.org or phone 012-841-4152. Find us on Facebook at National Metrology Institute of South Africa, on Twitter at NMI South Africa, Instagram at NMI South Africa, LinkedIn, National Metrology Institute of South Africa, NMISA, and YouTube, National Metrology Institute of South Africa, NMISA.